Hey everybody, we want to talk about pressure, say in a lake, at a depth in a lake. So, or an example, someplace else, maybe you have a long tube and you want to know pressure as you go down the tube. But the tube part is open, so it's kind of same kind of example. That will be like you have a tube, and I don't care what's on the other side is. Maybe you filled all of this up to here, but this is open. Okay, the closed tube depends on what's over there. But open tube, you know what's there is air, open air, right? So it's kind of that situation, this situation, similar, all right? So how do I get a formula for a pressure at, say, this height is h? How do I? We know that at this point pressure is atmospheric pressure. In the book, sometimes we also denote by P sub 0 for atmospheric pressure. Okay, we just apply the definition of pressure, right? So if we want to know the pressure here, so we will say, imagine an area such that I can work out the force on that area. So we imagine horizontal area rather than vertical area, okay? We imagine horizontal area because then we can say all weight of everything above that will apply a force on that. So we'll say pressure immediately below that is P sub h. So I have an area A, this area A. So you can say all these molecules, water molecules in that area. We want to know how much force on that area A. So let's call that the water molecules in that area is delta M. And so from below we have pH times the area A. That's the force from the below. This is the force from below on stuff that's in that area. Well, if that was only force, it can accelerate, right? But it's not accelerating. Acceleration, this thing is 0. So there must be a force from above. So you can see that I will say force from above is the weight of this plus the force on here. Okay? So force on here is P0 times A. So this is the weight of this plus F0. That's the downward force. So downward force is, and F0 is simply P0 times the area A. So P0 times the area A plus the weight of things that's in there. So we need to figure out the mass of that thing in there. So we need to know the density of this. So say density is rho. This is the density. So rho times the volume of this thing, A times H times G. So that's the force. This is the weight part, and this is the force that was someone, you might say, I'm pushing on. Suppose this was a cylinder and you're pushing on the cylinder. So your push plus the weight of the cylinder will act on those molecules over there. That I'm calling delta M. Now this must be balanced, right? This must be balanced. So if it's balanced, we are going to get pH force at height, pressure height times A, minus all of that equal to 0. So make it equal P0 times A plus rho A H G. So we can see A was arbitrary to begin with. I could have taken 2 millimeter square, 10 millimeter, I could have taken whatever area, right? And so my formula shouldn't depend on the area that's up to me to choose, some arbitrary. And nicely it kind of cancels out. So this area from each one of them cancel out, and so P at depth h is equal to P0. Usually we can write rho hg, but the way formula people have long, it's traditionally written as rho gh. This is a very important formula. Now this formula is only applicable if the surface was open to atmosphere. So because of this contribution happened because the surface was open to atmosphere. You can actually say what will happen if it was not open to atmosphere. So you say if I have something which is vacuum, and I have everything is closed. Everything is closed, and I want the height h. So what will be the pH here? Well, P0 at this point that will correspond to P0, but there's vacuum. There's no pressure there. So in this case, pH will simply be rho. If this is rho GH. Rho GH. Let's take another example. Not vacuum there. So I closed it here, but maybe I have some kind of stopcock and I fill with some gas in here. Okay, some gas above it, and this is rho. But the pressure here is P1. Let's call it P1. So I fill it with some pressure. And I want to know at this height what will be pH. Well, look at how I got the P0, where the P0 came from. So instead of P0 you have a P1. In this case you'll have a pressure at height h will be whatever the pressure at the top plus rho GH. So when we use these formulas, you have to be sure about what kind of situation I have that may add pressure onto the one that's straight from the weight. This always be there. This is in each case is always there because you can't take away the weight of the fluid above it, right? But you may affect whether you're pushing, atmospheric pressure is pushing more on it or not. Or maybe you press the gas, which can be considerably more than atmospheric pressure. So you can be more than that. Okay, this is a actually important lecture. You should kind of watch it again maybe and try to understand how to think about pressure at a depth in a fluid. So we'll talk to you in another video. Bye.